If you are wrestling with data in Google Sheets and feel like there is a better way to sort, filter, analyze it, or build dashboards, you are exactly in the right place. Imagine bringing the SQL-like power that typically is available just to data professionals, not regular spreadsheet users, directly into your Google Sheet. That is exactly what the query function is all about. Hey there, I'm Ievgen. You're at OWOX BI YouTube channel where we speak all things about analytics, marketing, spreadsheets, and all sorts of data manipulation. I am here to help you make your data work for you. That is our mission. Whether you are a data analyst, a project manager, a marketer, or a business owner, or even a C-level executive, or anyone else who interacts with data within spreadsheets, you're about to discover how the query function in Google Sheets can transform the way you work with data within just the next 15 or 20 minutes, maybe a bit more. Today, I'm going all in the what, the why, and the how. Prepare to bid farewell to time-consuming data handling and welcome a new era of better, smarter, and faster analysis within your spreadsheets. So, buckle up, grab your tables, and let's dive into creating powerful data queries that work hard so you don't have to. Without further ado, let's get started. Getting the hand of query function in Google Sheets can be a total game changer for you. As I mentioned earlier, it allows you to perform SQL-like queries directly within your spreadsheet, but way easier. It's a great function I use almost every day. And it's one of the Google-only functions that are not available in other spreadsheet tools. So, here is how the syntax looks like. It's pretty straightforward. You just type query, then you need to specify the range of cells that you want to perform the query on, the data you want to query. For example, in my case, this will be the range containing the sales data from B1 to D16. The next part is the query itself. This part of the function is where you write your SQL-like statements. This query string must be enclosed in double quotes. You can include various SQL clauses, but you have to follow the exact order. And finally, our third parameter here is headers. This is optional, but sometimes very useful. We'll get into it later. It is very important to follow the correct order of these clauses when writing your query to ensure it executes correctly. And this order is a bit different from the one in regular SQL. You can find the order of the statements on this image on the left. And by the way, I encourage you to drag this template from the description to this video. It's totally free. But when you do this, you will have all of my examples available in front of you. So here is the order of the commands within the query function that you should follow. Number 1. Select. This statement specifies the columns to be shown in the results. Number 2. Where clause. This one filters the rows to be shown based on specific conditions. Number 3. Group by, that aggregates the data across the specified columns. Number 4. Pivot. Well, this rotates the data for a better summary view. Number 5. Order by. This clause sorts the data in the specified column order. Number 6. Limit. When you need to limit the number of results, the number of rows you want to return, that's where you need to use the limit clause. Number 7. Offset. This one skips a number of rows before beginning to return rows. Number 8. Label. This one changes the label of the column for display. Number 9. Format. This one formats the data in the specified column. Number 10. Options. This one provides additional controls over the query execution. So, just keep this clauses order in mind when querying data using the query function in Google Sheets. Now, let's proceed by diving into the first practical example using the select clause, the first one on our list. Starting with the basics, the select asterisk statement is used to retrieve all columns from a specified range in your Google Sheets data. This is akin to selecting all fields from a table in SQL. So for our example, we type in query, then specify our range B1 to D16. Then open the double quotes, put our select asterisk statement, close the quotes, then parentheses, and hit enter. As you can see here, we pull every column within the range B1 to D16 of our table. This result mirrors the entire original table, displaying all columns: sales representative, region, and the sales amount. However, there are times when you might not need every column, basically is most of the business cases, but instead just specific ones from your original table. The query function allows it as well. You just need to specify the columns to retrieve. To list only the sales representative, let's just change our query a bit. To select B instead of select asterisk. To see only the regions, let's replace B with C. To check the sales amount alone, we can replace it with D. Or to list both sales reps and their sales amounts regardless of the region. Let's say select B, D. Each of these variations of the select statements inside the query function allows you to focus on only the relevant columns required for your analysis or report. Remember, our query function is in the cell G1, so the output will be the columns G and H. The B and D inside the query select statement refers to the column references back in the original data. Remember I mentioned there is a third optional parameter here. It's the number of rows in the header section. For our current table, we can specify that the first row contains our headers using the optional third parameter in our query function. This formula tells Google Sheets to treat the first row in our range B1 to D16 as headers, not as values. But sometimes you might encounter tables with headers that span multiple rows, like this one for example. Handling this correctly ensures that your data is accurately represented and that your queries return the expected results. So just once again, we have a table here with 2 rows of headers. Let's just adjust our query. So we type in again query, our range B1 to D16, then our select statement, select B, D, but we will set the headers parameter to 2 this time. This adjustment tells the query function that the first 2 rows contain header information, ensuring the data below is treated as the content of the table, and headers are not misinterpreted as data, and it concatenates the header row cells using the space between. Now we are diving into a next fundamental part of the query function, the where clause. This clause is essential for filtering your data based on specific conditions, ensuring that only the relevant rows that meet the criteria are returned. Let's see it in action with some practical examples from our data. The simplest use of the where clause is to filter data based on the single condition. For example, if we want to pull records where the sales representative is named John Smith, we would use the same query function. We would add the where statement here, where B equals John Smith. This query function sifts through the data and fetches the rows where John Smith is listed as the sales representative, displaying all related columns. Or instead of saying equals John Smith, we can say where B like John. Great, the results are the same, but basically we have retrieved all of the sales representative with the name starts with John. Or we can do the same for the sales representative starts with just J, and now we have Jane Doe here as well. Great, you can see our results. Similarly, we can filter by the numeric conditions. Say we want to find regions where the sales amount exceeds 5,000. So we will say where D is greater than 5,000. This filters and displays all rows where the sales amount is greater than 5,000. Or we can say greater or equals than 5,000. Here we go. And when we need more precise data extraction, combining conditions becomes useful. Suppose we want entries where the sales amount exceeds 5,000 or equals, and the region is Midwest. Here is how we do it. We use the word AND between the two conditions inside our where clause, and we specify that C equals Midwest. This will provide a focused set of data from the Midwest region with the sales exceeding 5,000. So we just have one row like that. These examples illustrate the power of the where clause in narrowing down your data to meet specific analytical needs. By applying these filters, we enhance the specificity and relevance of the data extracted for reports or further analysis. Moving on, we will explore how to manipulate this data further using the other clauses in the query function. Continuing with our exploration of the query function in Google Sheets, we now focus on organizing our filtered data using the order by clause. This is crucial when you need to sort your results in a meaningful order, either ascending, the default one, or descending. Let's apply this to our dataset, where we've already filtered entries with some sales amounts that are over 5,000. So starting with the basics. If we simply want to sort the qualifying sales amount in ascending order, we just need to type in order by D and click Enter. This command arranges the sales figures from the smallest to the largest, making it easier to see the progression set of values. Often, you might want to see the highest values at the top. For this, we use the descending keyword at the very end after the order by. This flips our previous order, now displaying sales amount from highest to lowest. To add a bit more complexity and utility, you can sort by multiple columns. Here, we might want to see the data sorted by the region first, and then by the sales amount in descending order. So we'll add C here before D. So sort by column C is ascending, by D is descending. If we want to flip this around, we can just add the descending here after the C but before D. This argument basically first groups the data by region, and within each region the sales figures are listed from highest to lowest. This type of sorting is particularly useful when dealing with multidimensional data where understanding hierarchies or layers in the data is necessary. Each of these order by examples demonstrates how you can control the presentation of your data with the query function, making it more digestible and tailored to your specific requirements. As we dive deeper into the capabilities of the query function, the group by clause plays its role when you need to aggregate data based on specific attributes. It's particularly useful for summarizing or grouping results to draw insights from the dataset. Let's explore how to use this clause to aggregate sales data in different ways. First, we might want to understand the total sales generated by each sales representative, irrespective of the region they operate in. Here is how you can achieve that. So, select B, sum D, sales amount, then group by B, the sales rep, and order by sum D, the total sales amount, descending. This will group our data by the sales representative, calculates the total sales amount for each rep, and then orders the results in descending order of the total sales. It helps in quickly identifying the top performance. Now, we want to analyze the performance by region, so we need to slightly adjust our query here. Just replace B with C and hit on Run. This formula groups the entries by region, sums up the sales amounts within each region, and then sorts the regions by the total sales. This is cool for regional performance analysis. For a more detailed analysis, we can combine multiple criteria for even deeper insights. So we can add B here back again into the select statement and to the group by statement. The rest stays the same. So here the data is grouped by both the sales rep and the regions. This approach shows a layered perspective of sales data. Each of these group by examples builds on the basic aggregation concept, showing how to customize data summaries to fit specific reporting needs. We've already discussed a bit sum aggregation, but there are more of the functions like that, and they are so powerful. So here's how you can apply them to compute summary statistics over groups of data. For the detailed insights into sales performance by region, we might want to see the minimum, the maximum, the average, and the total sales amounts. So here is the query. So we type in select C, min D, max D, average D, and then sum D. Group by C, header 1, here we go. This query breaks down sales by region, providing a comprehensive view of sales dynamics, including the lowest and the highest sales amounts, the average sales amount per region, as well as the total sales for each region. If we want to analyze performance by each sales representative, we can adjust this formula by replacing C, our region, with B, our sales representative. This configuration lets us set the range of sales amounts handled by each representative, their average sales performance, and their total sales, enhancing the performance evaluation. Okay, we already know how to calculate the sum. Let's do it here in a separate cell. So, query our range, then select sum D, header 1, that's it. This gives us the total sales amount. Now, to find out how much each sales representative contributes to the total sales, we can use the sum obtained and perform arithmetic operations directly within a query statement or through the cell references. So query our range, then select B, comma, then open parenthesis D divided by 73,500. And don't forget to close the parentheses. Here we go. Or we can change the number with a cell reference. So we have to kind of get out of the query by entering the double quotes, then ampersand, cell E2, then ampersand again, and double quotes again. Here we go. So cell E2 contains the total sales amount from the previous query. This query will list each sales representative alongside their contribution percentage to the total sales, providing a clear breakdown of individual performance relative to total sales. These examples demonstrate the flexibility of the query function in handling complex data operations that are typically reserved for robust databases right within Google Sheets. When working with grouped or aggregated data in Google Sheets, especially when using the query function, the default headings for computed columns can be less descriptive, making your output less clear or professional looking. The label keyword comes in handy to address this by allowing you to rename these headers to something more meaningful. Continuing from our previous example, to make the output more understandable and visually appealing, especially when presenting data to stakeholders or in the reports, you can rename those headers using the label keyword. The label keyword should be placed at the end of your query statement, exactly in the order following this image here on the left. So we just add the label keyword, then specify the column we want to rename and give it a name. Great! This modification to the query function specifies a more descriptive label for the column with the contribution to the overall sales. This makes it easier for anyone reviewing the data to understand the results without needing to decipher what each column represents. Let's now explore how to utilize the limit keyword in Google Sheets query function to control the amount of data displayed in your results. Sometimes you just need the first 10 rows, or even the first 5 rows, most meaningful records based on certain criteria. So first, let's start with a very basic query that retrieves all records here. So we have all of the rows and all of the columns. Now, suppose we want to restrict the output to just the top 10 records. We can do this by adding a limit clause to our query function. Just type in limit 10. This adjusted query function now returns only the first 10 rows of our dataset. To further narrow down the results, perhaps for a brief summary or report, we can change the limit to 5. Just replace 10 with 5. It's an effective way to focus on the top results, whether you are showcasing the highest sales, most active regions, or any other top-performing metrics within your data. Now we're stepping into something incredible here. That's about creating pivot tables directly with the SQL-like syntax using the pivot clause in the query function. This is particularly handy when you want to transform your data to see a cross-tabulation of summary that spreads across multiple dimensions. Let's say you want to see the total sales broken down by region for each sales representative. This is how you can structure your query. So we basically select sales representative's name, column B, and then the sum of the sales, sum D. We group the results by the sales representative, group by B. We then pivot the data by region, pivot C, creating a column for each region with the corresponding total sales for each sales representative. So just once again, select B, sum D, group by B, pivot C. Look how nice it is now. If you want to exclude certain data, such as sales from the West region, and then pivot the remaining data by sales representative, just add the where clause, so where C is not equal to West. The rest stays the same. These examples demonstrate the pivot clause's ability to restructure and summarize complex tables, making it easier to analyze trends and patterns by different categories. If you want to learn more about the built-in pivot table feature, I'll leave a link in the description to this video, but you can also find it right here. Basically, there are 3 more statements for the query function in Google Sheets. First, it's offset. This clause allows you to skip a specified number of rows before starting to return the rows from your query. This is useful when you want to ignore a certain number of rows at the top of your dataset, often used in conjunction with limit to paginate results. Second, the format clause is used to format the data returned by the query. You can specify the format for dates, numbers, or the other data types directly within your query, making the result more readable or display-friendly without altering the data in the cells themselves. And the last one, the options. It provides additional controls over how the query executes. For example, it can be used to specify whether the calculation should be case-sensitive, among other settings that can tailor the behavior of the query function. When utilizing the query function in Google Sheets, encountering issues is common, especially as your data manipulation needs become more complex. Here is how to address some typical problems. Number 1. No results found. This happens because the query conditions are too restrictive. This issue arises when the conditions specified in the query are too narrow, leading to 0 matches. To remedy this, loosen the criteria by adjusting the query conditions, ensuring they accurately encompass the data you aim to analyze. Number 2. Invalid data reference or cell conflict. This error signifies an issue with cell references within your query, possibly pointing to deleted or moved cells. Correct this by ensuring all referenced cells and ranges are in your query function, and it's still valid and it still exists within your spreadsheet. Number 3. Parsing errors occur if there is a mistake in the query syntax or if essential parts of the query are missing or misplaced. Review the query string for any errors and conflicts, so you're gonna be good to go. Number 4. No column error means that the selected columns is outside of the available range. Basically, when you reference columns not included in the specified range of the data source, this error will appear. Check the column references in your query to make sure they align with the actual columns available in your data range. These tips should assist in troubleshooting common problems, making your experience with the query function smoother and more productive. And there you have it. Today, we've gone through everything from setting up basic queries to harnessing the power of advanced SQL-like operations right within the Google Sheets. We've tackled select, where, order, group by, pivot, and so much more, equipping you with the tools to handle complex data analysis within Google Sheets. If this video has helped you understand the query function better, why not push your skills even further? No, I'm not gonna be selling you anything. Just go download the Google Sheets template linked in the description below. It's filled with all of the examples we covered today, allowing you to practice and master this technique yourself. Don't forget to give this video a thumbs up and subscribe to our YouTube channel for more in-depth tutorials. Hit that notification bell to stay updated with our latest videos crafted to enhance your spreadsheet skills. Thanks for watching, thanks for tuning in. I'm Ievgen from OWOX, and remember, mastering this Google Sheets function isn't about data manipulation. It's about turning the data you have in the business into the insights that drives better decision and growth. So keep spreadsheeting, stay data curious, and happy analyzing.